Welcome to a new test and teardown video. This time it's an AC voltage stabilizing or regulating unit. It is from Wandel und Goltermann. Wechselspannungsstabilisator. Super. So, this thing is from about 1957. Amazing, huh? I just spent half an hour polishing and cleaning the front here so I could make it this nice and shiny again. It is quite big. Oh, we got some corrosion like that. It is not so good. Probably just some storage. I hope it's not inside. And we got some really nice handles. This thing here is, 22.4 kilos, so it's quite heavy. Yeah, I better open and inspect before we can play with this. Let's try and look inside, huh? So yes, it is definitely tube based. We got two double triodes and a big power EL34 right there. And we got quite a lot of transformers. There's a big powerful transformer here. And I think if you add all these, that explains the 22.4 kilos. We got a few special interesting components as well here on the back. I think that will be voltage dependent resistors, VDRs. And there's another one at the bottom. I'll show you. Here in the middle, I think this bulb together with these components will be the oscillator. So there is an oscillator obviously running at the 50 Hertz, and it's regenerating the sine wave on top of the incoming sine wave via a series connected transformer to the input mains. So that means all those thousands of watts that it can deliver, it's only the 20 volts, see, the plus minus 20 volts here. This is the regulation range. You can adjust using the output voltage setting, right? And then it superimposes, like in series with the incoming AC, a perfect sine wave that is of course in phase and locked to the incoming sine wave. And then it is fully feedbacked. So it's measuring the output voltage and it's feeding this back to the system. And then it power drives only the 20 volts using this power tube. And that is how you can do this. I think I should show you the schematic in a little while. I will show you how I think this thing works. So here's the bottom of the unit. Here you get a really good picture of the main power transformer. And I believe that is the other VDR. So they're supposed to get warm. And so far I haven't found any leaked, burned, missing, damaged components or anything like that. Only a little bit of corrosion like that. It's not really affecting anything. Nothing, should stop me from power this up, really. So let's try and do that. So just before I power this up, I mean, let's just pull the suspense a few more minutes, right? I've been cleaning up and I've been deep investigating everything here. And yeah, I think it is ready to power up. What I want you to see here is the main components. I will go through the schematic. So what you need to note here is the transformers and the power regulator tube. We got C16, we got U3. They call the different transformers for U. I don't know exactly why. That is C14, D1 and D2. That is those are really interesting, by the way. I believe we got some phase shifters, filters here. They are coupled really interesting with the power transformer. And of course we got those voltage dependent over voltage protection devices. And yeah, we got the oscillator and the voltage feedback system here. And I believe that bulb here is for the oscillator level. And on the bottom side, I've already shown you the bottom side. It's also a few transformers and inductors and all that kind of stuff that is used for coupling the signals to the power tube and the oscillator and all that kind of stuff. Not super interesting to look at. We have already seen it. Let's look a little bit on the schematic. Thank you very much, Radio Museum, for the schematic. So please support these guys. All right, here in the middle, you see the transformer, and that is used to pump up the output voltage in relationship to the input voltage. The way this works is, let's pull out EL34. So now that tube is not mounted. No current can go through U4 transformer. Okay, so now there's also nothing added to the series transformer that can rise the output voltage. So when you put in 220, for example, this is what this unit was designed for, then you will get 160 on the output. All right. So if we plug in EL34 and we drive it absolutely maximum on, so that means if there's no drive signal or nothing that comes into its grid, that means it's going to be turned on completely. It's going to pull maximum current, and this way it's going to short the transformer U4 and therefore also destroy the resonant circuit of the two capacitors and the two inductors up there. And now you're going to raise the output voltage. So that is actually how this system works. And the fun thing is that EL34 seems to be driven on a DC, but that is not the case. It is running on a 20 kilohertz sine wave oscillator, and it's measuring the output voltage using two windings in series, and this voltage goes into a 20 kilohertz oscillator, and this way it's going to affect the output voltage, the 20 kilohertz output voltage that is driving the EL34. And this explains how it's possible to deliver that many watts and that much regulation span. So you're going to get 220 plus minus 60 volts. Because if you short circuit EL34 or drive it completely on, you're going to get 280 volts output. That is your maximum output, depending on how much this is driven and how the pulse relationship and all that kind of stuff is. Yeah, you will have the 60 volt regulation range. And so that is, I think, quite fascinating. you will see the EL34 tube and the other two tubes and all that circuit stuff is chassis ground related. And that is of course perfectly fine because we got isolation transformers. We are measuring the voltage using transformers, and we're also driving the output from the EL34 to the two resonant circuits. That's also using an isolation transformer. And then to the very left of the circuit you have the U2 transformer. That is the power drive to the EL34 as well via an isolation transformer. And there's another fun thing about this circuit. The output, this is where you have to the upper right, you have a U1 transformer. See, this is also the voltage sense transformer, but this is also driving the filaments. So at power on, you're going to get the lowest output voltage of 160, and then slowly the tubes, they're gonna start warm up, and then the voltage will always start from minimum and then rise up to whatever your potentiometer is set for. I'll try and do the very first power up now. I believe that I should turn this on first, and then I set the power to 500 and voltage here is in the middle, just to see that it's not, we should dim the light, right? Let's turn off all the light here so we can see what's going on. And then I will turn on my mains. And then I will just slowly monitor. That is a good sign, because I also see output. I think I just dare to crank it all the way up, because this is exactly what I wanted to see. So now I have 220 input. I will try and manipulate my input vario to hit exactly 220. And my output is 156. And let's try and see if there's any response of the output voltage. Nope. But listen. This is because the tubes start to warm up. Oy, 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 oy. Oh, it's cranking it up. I don't have regulation. I have 280 watts of output. Oh my God, it is over smashing, and there's no regulation. I have to crank this. Oy, 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 oy. Scary stuff. But okay, it can definitely crank up the power. And there is some sort of stuff with the regulation here that is definitely not working. My pulse is going down to normal. Cool. So with the EL34 mounted, we got 280 volt output and no response on the voltmeter. So that means that power tube is working because it's able to pull up the voltage. However, we didn't have any response on the voltmeter, volt setting potentiometer. So that means there's no feedback. The oscillator is working, however, because that oscillator is needed to drive the EL34. So now my idea is I'm gonna take two brand new ECC81s and plug in and see if it's better. I think I got a major breakthrough. I've been, of course, starting to measure a little bit. Have we got the oscillator here? No, we only got 50 hertz on the bulb and all that kind of stuff here. And all this circuit here is supposed to work at 20 kilohertz, But none of that happens. And that is because C14, we don't get any voltage at all. No AC, no DC, no nothing on that one. So that is what I want to follow. C14, we should have 260 volts on that one. And that will be the power supply for the oscillator and regulator. Haha. So if we just take a super fast glimpse over the schematic again. GL1, C13, and C14 is that yellow wire here. And we know that we don't have any voltage on C14. And there's a high risk of this resistor is probably not working so good anymore. And as you see, the red wire, that is the positive from that one. So why is this not working anymore? It could also be a short in the rectifier bridge. So AC currents, they're way too high. And that is a common failure of these types of rectifiers. But there could also be something else that is shorted, or somebody did poke around with something somewhere, and then we had a short. There's a high risk if I just replace this resistor, we're going to see it blow up again. Like you saw on the schematic, C13 handles the biasing for those two tubes, and that one looks like it is also bad. With all that corrosion coming out of its end here, it's actually kind of corroding through. So that one is of course the reason for the current, for using all that current on the high voltage. And that will just blow up this 1K series resistor. So here's another 1K. I just left it right here so it's not touching anything. And a new 10 microfarad for all the biasing. So I believe we should try and power it up again. So I'm ready to do that. I will of course monitor both my C14 voltage and the output AC. And my set point for output is just cranked all the way down. So let's crank it up. See? Now I get voltage for my oscillator tubes. And if we start to see any smoke, I will of course turn it off real fast, okay? So that is the 160 volts we have, and then we'll get a warm tube in a minute. And then I will start to investigate. Now it should start. Hopefully we'll see regulation. Look at that. What happened here is regulation. It is now stable. And look at that. This is our output voltage. And I can now go up or go down. Hee hee. It is working. And I can now generate a voltage that is higher than my input voltage. So I have 220 volt input and I have 220 volt output. Oh, this is not annoying. Sorry about that. And then I should be able to crank it up. 230. So this thing can give me higher output voltage, and it's nice and it's regulated and all that. So let's try something funny. Let's keep this at exactly 230 like that, right? Now, while we are watching this meter, I will take my other hand here and I will lower the input voltage just a few volts and see if it's in some sort of regulation, okay? So this is 220. That is 214. Let's go up again. 226. I mean, as you can see, we have now fixed this unit. Hee hee! How nice!